We inherit some properties and behavior from our parents, grandparents, and even from our ancestors. Since Java objects are close to real-world objects, they can inherit their properties and behavior too. In this chapter, we're going to look into inheritance, super keyword, polymorphism, typecasting, the final method, abstract classes, protected access specifiers, garbage collection, enum type, and a lot more. Stay tuned.
In this video, I'm going to talk about inheritance. Let's say we have a person A, and he's pretty good at playing tennis. Let's say A gets married and gives birth to Mr. B, who is pretty good at playing football. Now B will also inherit some of the properties from his father A. That means, apart from B's ability to play football, he can also play tennis because he inherited such properties from his father. And B is naturally talented in playing tennis as well. Now let's assume B gets married and gives birth to Mr. C. C will inherit properties from his father as well as from his grandfather. So C can play tennis as well as football. Apart from this, he will have his own individual talent of playing hockey. What I'm talking about here is the inheritance, the ability of a person to inherit some of the properties from another person. How do I explain this in the context of Java? Let's say we have a class called animal. If I have to write a Java program for the animal class, then I would have the following methods: walk, run, or maybe sleep, etc. Now let's say I have to write another class for dog. Now dog can again walk, it can run. Apart from these two, it can also bark. So why should we write this code again? Instead, why don't we just inherit such behavior from its parent animal? Every dog comes into the category of animal, so it's okay to inherit some of the properties and behavior from the animal class. The Java way of inheriting properties and behavior from another class is by using the keyword called extend. So we say dog extends and then the class name animal. So essentially we're extending the abilities and behavior of the dog. When we create an object, we can not only access the methods inside the dog class, but also we can access the methods inside the class from where dog class has inherited. That means the animal class. Hope that's pretty clear. Now we can also have another class, say puppy class, and it can inherit some of the properties from dog. So as we go down the hierarchy, we're becoming more specific, and as we go up the hierarchy, we're getting more generic. So that's what is inheritance in Java. In this example, the animal class is called a parent class or a superclass or a base class, while the dog class is called a child class or a subclass or a derived class. Dog is a child class of animal. Puppy class is a child of dog class. Hope that's clear. Let's take a look at one last real-world example. Let's say we have a robot class. Then it can have methods like start, walk, use navigation, something of that sort. Now we can have another class which is a cleaning robot, and it will extend the behavior from the robot class And in addition to all these behaviors, cleaning robot can also do the job of cleaning. If you observe one thing, everything in here is having an easier relationship. That means dog is a kind of animal. A puppy is a kind of dog. Similarly, cleaning robot is a kind of robot. Hope that makes sense. Let's talk about types of inheritance. We have 5 types of inheritance in Java. If we have 2 classes A and B, and if B extends A, this is called single inheritance. And we have multi-level inheritance wherein we'll have 3 classes. C will inherit the behavior from B, and B will inherit the behavior from A. This is called multi-level inheritance. We have seen an example of this a moment ago. Similarly, we can have a class, say animal. We'll have class called dog, which will inherit the properties from animal class by extending. We can also have another class called cat, which will also inherit the behavior from animal class. This is called hierarchical inheritance. So essentially, dog class will extend the animal class, and even the cat class will extend the animal class. Let's talk about multiple inheritance, wherein we'll have a couple of classes A and B, and we'll have a class C which will extend the behavior of both A and B. Java does not support multiple inheritance by extending 2 classes. That means C cannot extend the behavior of A and B. We have a problem with that approach, and I'll discuss that at later videos. Similarly, we have hybrid inheritance, wherein we'll have class A, we'll have class B and class C. B and C will inherit from A, and we'll have class D, which will inherit properties from both B and C. Even this is not possible in Java. But that being said, Java does support multiple and hybrid inheritance using interfaces. So let's preserve these 2 for next chapter. In our next video, we're going to take a look at examples of these 3. Now let's go through some of the examples. Before that, let me just show you how to import this project into your Eclipse environment. Click on File, click on Import, choose this option, Existing Projects into Workspace, click Next, choose this radio button, which is select Archive File, click Browse, choose the zip file that I have bundled along with this chapter, click Open, and click Finish. That should import this project into your workspace. Once you do so, open up these files. We have a class called living being, animal, and dog. What I'm talking about here is multi-level inheritance. We have 3 classes. Dog class is extending animal class. Animal class is extending the living being class. If we create an object of class dog, then it will inherit properties of both living being as well as the animal. That's exactly what I'm demonstrating here. We have a dog object here, and I'm able to call all the methods from these 3 classes. Since we talked about multi-level inheritance, this should also suffice for single inheritance. Now let's talk about hierarchical inheritance. For that, I have another class which is cat. Both these classes, dog and cat, will belong to animal category, and hence these two will attain the properties and behavior of an animal. Dog class extends animal, cat class extends animal. If I create an object of cat, then as you can expect, it can access the behavior or the methods from its parent and grandparents. Let's run this program. You can just run it right away from here. There you go. If you're interested, you can just go through all the output. All I'm doing is I'm just printing these strings. Hope that's pretty clear. And when we talk about interfaces, we'll cover the problems we have with the multiple and hybrid inheritance in case if we use classes to extend their behaviors. For now, they should suffice. See you in my next video. In this video, I'm going to talk about a keyword called super. Super is a keyword that we can use to access the parent class or superclass constructor, method, or member variables. Here is the example for that. I'm just creating an object of class dog that will invoke the dog class constructor. Inside that constructor, I'm using the keyword super to call the superclass constructor, which is animal. In that I have a default constructor with in which we're just printing a string. We're also able to call a method inside the superclass by using the super keyword. We can also access the member variables with super keyword. This is essentially like this keyword that we had talked earlier, but super is for superclass. Let's run the program. It worked. Animal class constructor from this instruction, and we got walking from this instruction, and we're able to access the member variables without any errors. That's great. And finally, we're printing this string. Also note that when you're calling a constructor of a superclass using the super keyword, then it has to be the first line of the constructor. For example, if I just cut this and paste it in here, we get an error. Let's see what that says. It says constructor call must be first statement in a constructor. So that's invalid. I cannot keep this statement in here as well. It has to be the first statement. Even if you don't specify super in here, by default Java compiler will implicitly put a super statement in here. If you don't believe me, let me run this class and we'll get the exact same output as before. So Java has implicitly put the super keyword in here to call the parent class constructor. To demonstrate the same in more detail, let me just get rid of all these two. Let me just get rid of these two lines in here. Let's save the file. Let's do Ctrl+Shift+F to give a proper indentation to the code. We have a constructor in here. Let me also uncomment this constructor in living being class. Let's save the file. We have three constructors in all these three files. We no longer need it. Now by creating the object of the dog class, it's going to call this constructor, and implicitly Java will put a super statement in here. So super would be called. That means it will invoke the constructor of animal class, and even in here the first statement of this constructor would be super. So it will call the constructor of living being. So we'll see this message first, and then we'll see animal class constructor, and then we'll see dog class constructor. Let's try to run this program. There you go. Now, just in case if you get rid of the default constructor and make use of some parameterized constructor, let's say int x or something, we would get an error because it is expecting default constructor to be present. In order to fix this error, you'll have to explicitly use the super keyword and use that constructor of the parent class. That way we'll get rid of the error. Now this brings me to talk about a couple of other topics: instance initializer block and static block. Let's talk about them. Let's first talk about instance initializer block. Let's say we have a couple of more constructors in here with, say, int y and a default constructor. Save the file. Now let's say there is a piece of code that is common in all these constructors. I'll have to write it repeatedly in each and every constructor. There's a workaround for this. We use instance initializer block. It's just an empty block with a couple of curly braces, and inside which you write all the instructions that you want to be executed before executing any of these constructors. Let's do system.out.println. Now, no matter which constructor you call, it's going to first execute this block. Let me demonstrate you that. Now, instead of dog class, let me just create an object of the animal class. Let's run the program. So first, the living being constructor got executed, and then the instance initializer block, and then the animal class constructor. So what has actually happened? When we created an object of animal class, since we didn't send any parameters in here, it's going to call the default constructor. The first statement of the default constructor would be super. This will call the constructor of the super class, and hence we have seen this message, living class constructor. And the next statement would be to call the instance initializer block, and hence we see this message, instance init block, and after that the actual constructor will get executed. By looking at the output, you may be tempted to think that this is called first, but actually the constructor will be called first, but the instance initializer block will be called before executing the statements in the constructor. So somewhere in here it will call instance initializer block. Hope that makes sense. So whenever we create an object, it will call the constructor first, and then the first statement of constructor would be super. If there is no super class present, then the first instruction is to call the instance initializer block, and then the rest of the statements in the constructor would be executed. Hope that makes sense. Now let's talk about static block. The way you represent static block is the same way you represent an instance initializer block, but with the word static. We've talked about the keyword static many times before. When we say static, this block is associated with the class, not with the object. So this block in here will be executed only once per class, no matter how many objects you create from that class. And this would obviously take the highest priority. In fact, it's not about the priorities. Before even creating the object, this block would be executed, and then the rest of them would come into picture. Let's say static block, and let's run the program. Static block and rest of the instructions follow. So when will the static block gets called? A static block will get invoked when the class is first loaded. That means either when the object is created or when one of the static members is invoked. For example, we have, let's say, a method which is of static say void some method, and system.out.println static method. Let's save the file. Now I can just use the class name to access that method since it's static. So that's animal dot some method. Let's run the program. Fair enough. Static block and then the static method. Alright, hope this all makes sense. See you in my next video. In this video we're going to talk about InstanceOf operator. It does exactly what it says. It will check to see if an object is an instance of the specified type, and it will give us a Boolean result. Let me just demonstrate you what I meant. Let's say we wanted to validate this statement in here. So we want to check to see if this object is an instance of animal class. So what we're going to do is system.out.println, and we're going to say is any object, any obj, instance of animal. Of course, let's get rid of the statement. Let's run the program. True. Alright, let me just pause the video and comment out all these lines. They're a little misleading. Alright, here we are. Let's run the program. Now let's try to do the same for this statement. Let's do Control C and Control V. This will give us a compile time error because cat and dog are two distinct types, just as we got a compile time error in here. Let's try to do the same for, say, this statement. Let's copy this, paste it over here. Any object belongs to a dog. Let's try to see. It's not. Let's try to do type conversion. Save the file and try to run it again. Class cast exception, just as we got with this statement. Now instead of any object, let's try to do it with A1. I would expect the result of this statement, which means our explicit typecasting should be successful. Let's try to run the program. True. Great. Hope we got a sense of what InstanceOf operator is, and this is going to be a pretty useful operator in future. Okay, in this video we're going to talk about polymorphism. Polymorphism is the ability of an object to perform the same action differently depending on the context. Let me explain you what I mean. Let's take a real-world example. Let's talk about a cat. Let's say a cat will run at a speed of 10 km per hour. Now if a dog is chasing the cat, then it will run faster, maybe 15 km per hour. So depending on the context, the cat is acting differently, but the behavior is same. Ultimately the cat is running, but the speed is varying depending on the context. That's exactly what polymorphism is. So in here, in the cat class, we have two methods. Both these methods perform the same action, which is running. But in this run method, the cat will run at 10 kilometers per hour. In this method, it's going to run at the speed whatever I send as a parameter. In our Java program, I've created an object of that class, cat. When I do cat object.run, it's going to call this method. When I do cat object.run, by sending a parameter, it's going to run this method. So what we have done is overloading, which we have seen in our previous example. The point I want to make here is ultimately the cat is doing the same job of running, but it is running differently. This is called compile time polymorphism. That's because during the compile time itself, the compiler will know which method to call. Although the name of the method is same, the signature is different. I mean, either the number of parameters or the type of parameter is different, just as we looked at in our example earlier. Now let's talk about runtime polymorphism. Just as we took real-world example for compile time polymorphism, let's take a real-world example for runtime polymorphism. Let's think of an animal. Every animal screams, but the way the scream will happen is dependent on the animal itself. Take a look at this example. In this animal class, we have this method screaming. But if you see, a dog will scream like a dog. So we have a scream method in the dog class, and it's going to scream like a dog. The thing here to understand is we have the exact same signature as to that of the scream method in animal class. What we did here is overloading, where we have two methods with the same name but different signature, and Java will not let us write two methods in the same class with the same signature. But it's possible in overriding, because in this class, this is the only scream method with this same signature. Now let's understand what is runtime polymorphism. In this class, we have an animal object, and using that object, I'm going to call the scream method. This instruction will call the scream method inside the animal class. But whereas if we have animal reference type, and if it points to a dog object, then this instruction will result in calling this scream method. So depending on the type of animal, the scream method will act differently. Ultimately, it's just screaming. Now again, if we have, let's say, a cat class, then we can have the same exact method. Scream like a cat. Now let's copy this code, paste it over here, cat and cat. Now this scream method is going to call the scream method of cat. Hope it makes sense. In order to make sure that the method that you wanted to override is indeed overridden, you're going to use the annotation called @O overwrite. This annotation will make sure that this method, the method that is next to it, is overridden. If you make changes to this method, for example, give it a different name, it's going to throw us an error. Or if you add another parameter, it's going to throw us an error. Let's see what the error says. The method scream int of type dog must override or implement a subtype method. We're going to override, but what is implement? We'll know about implement keyword when we talk about interfaces. But for now, let's undo the changes. Let's keep this annotation, it's a good practice, and I always encourage you to do the same. So the point I want to make here is, depending on the type of object to which this reference type is pointing to, it's going to act differently. Ultimately, all these objects are animals, but an animal can be a dog, an animal can be a cat, and depending on the type of animal, we want to trigger its respective behavior. Hope that makes sense. This is called runtime polymorphism. That's because during the compile time, compiler cannot make out which screen method to call. Should it be the screen method inside the animal class, or should it be the screen method inside the dog class? It just can't make out. So the JVM would be able to do that. It's going to override the method inside the animal class, and depending on the object it is pointing to, or we call it the true object. So the screen method will call the method inside that true object. Now where's the typecasting here? Java has done that for us. What has happened in this line is widening. Every dog can be an animal, so it's widening. But in case if you wanted to utilize the method inside the dog, then you can always do explicit typecasting of this animal to dog. For example, you can have a statement that says something like this: dog D equals, just copy and paste it over here. The auto suggestion will actually fix the problem. It will automatically convert this object to dog. It will suggest us to convert this object to dog. And now you can always call attain the behavior of dog on the D object, d.bark. It's valid. But whereas if you're trying to do the same with any object whose true object is animal, then this would yield a compile time error. For example, you can't do this. It will result in compile time error, class cast exception. Let's undo those changes. Another point which I want to point out is this will actually make our life a little easier. Let's say we have a method that's just going to print the details of that animal, let's say. So print details static. This has to be static. The reason is this is a static method and we can only call another static method, and inside this we have something that does something. This is not going to return anything, and the parameter that we send is animal A. This way this method can accept literally any animal. And let's say we have 100 different types of animals like dog, cat, crocodile, elephant, etc., and they all inherit the behavior or extend the animal class. So we don't have to write 100 different methods for each and every object. We don't have to have the same method written for dog and the same method written for cat, etc. Instead, we can just send the parent class object by doing it in this manner. If you want to send dog, you can just have a reference type as animal, but point to a dog object and send this as a parameter to this method. And inside this method, we do narrowing, a valid narrowing that doesn't result in class cast exception, and we do anything that we wanted to do inside this method. Hope that makes sense. See you in my next video. Alright, in this video I'm going to talk about typecasting in Java. We had already talked about typecasting for primitive data types. Let me just go through it once again a little bit. Let's say you have byte b equals 10, and we're trying to assign this b variable to int type. What's happening here is Java is automatically converting this byte value to int. This is automatic type conversion and is done by Java. But in case if you want to do it the other way, for example, if you have int I equals some number and you have byte b equals I, this is going to result in compilation error. That's because we're trying to convert a higher type value with higher range to lower type value, byte. Java does not typecast this implicitly. We programmers have to typecast this explicitly. So how do we do that? We're just going to typecast it to byte. Now since the range of byte is way less than this number, by doing this operation is going to result in some loss of data. We had discussed about how loss of data happens in the beginning of this chapter. But let's say we have int I equals 10 and byte b equals byte of I. Now in this case there is not going to be any loss of data. That's because number 10 falls in within the range of what byte supports. So in this case what we're achieving is widening. We're trying to convert a lower type data type to a higher type data type, and Java implicitly does typecasting. But what we're doing here is narrowing. We're trying to convert a higher type data type to a lower type data type. Hence it's narrowing. You can actually think of it in this manner. Let's say you have a box which is, say, int, and you have another box which is a smaller box which is of byte. You can easily insert this box inside the int box. But if you try to do it the other way, I mean trying to put in int inside the byte, then we can't, it's just not possible. There's definitely going to be some loss of material. Hope that's clear. In Java, typecasting is not only applicable for primitive data types but also non-primitive data types. Let's take our example of animal. We have living being class, and we have animal class which inherits or which extends living being, and we also have a dog class which will extend animal. As we're going up the hierarchy, we're getting more generic, and as we go down, we're getting more specific. Now if you observe, every dog is an animal. It has an easy relationship, and every animal is a kind of living being, but not the other way. Every living being doesn't necessarily have to be an animal, and every animal doesn't necessarily have to be a dog. So when we're trying to convert dog to animal, it is called widening. It's acceptable, and Java does type conversion on its own. But when you're trying to convert animal to dog, it's narrowing. And just as for primitive data types, narrowing typecasting needs to be done explicitly. Let me just explain you with a couple of lines of code. Let's say you have a dog class object. You have a reference type of animal, and you're assigning this object to animal. Java does implicit typecasting in this case because it's, as I've explained, every dog can be an animal. But let's say if you're trying to do this, you got animal equals new animal, and then you're trying to assign it to a dog reference type. But for this, you need to typecast this explicitly by doing dog the animal object. What this is going to result in is class cast exception, because ultimately you're trying to convert animal class to dog class, and Java is not aware of your class and objects to deal with the loss of data, so it's just going to simply throw us an error saying class cannot be converted, it cannot be casted. So it's just going to throw us an error saying this conversion cannot happen. I just cannot convert a higher type data type to a lower type data type. So when do we ever be able to use explicit typecasting without an error? Is when you do this. You have animal reference type, And instead of creating an object or pointing to an object of animal, you're going to point it to a dog object. And this is allowed obviously because every dog can be an animal. Now you have a dog reference type, and you're going to assign animal object to this. Again, this requires explicit typecasting. Java does not do implicit typecasting. So what you're going to do is, I want to convert A to dog object. Now if you run this program, this is not going to give us any runtime errors. That's because ultimately it's the same type. Why do you ever want to do this? Is to achieve one of the major features of object-oriented programming language, which is polymorphism. We're going to talk about runtime polymorphism in this chapter anyways. Alright. In some cases, Java does throw compile time errors when we're trying to convert two incompatible types. For example, we have animal class and we have dog and cat. And dog and cat are inheriting some properties from animal class. Now in this case, if you have a dog class object, new dog, if you have cat or cat reference type, and you're trying to assign this object to this cat reference type, this is not possible even if you do explicit typecasting, because as a rule of thumb, just remember that when you're trying to do a typecasting, or if you're expecting an automatic typecasting, then both the data types must fall in the same hierarchy. For example, you can have living being here. If you're trying to do typecasting within this line, then it's allowed. You can't just do typecasting of these two independent types. And that perfectly makes sense, because dog and cat, even in the real world, are two distinct objects. This is the beauty of object-oriented programming language. You can always correlate all the concepts of object-oriented programming language with the real-world objects in the real world. Now let's go to our program and take a look at all these examples. So here we are. We have an object of living being, an object of animal, dog, and cat. Now I'm going to uncomment these lines one by one, and I want you to make a guess on the expected result. Let's uncomment this line. Is this valid? Yes, it is valid. That's because we have an animal reference type and we're assigning an animal object. So animal and animal, they both are of same type, no worries. Well and good. Now how about this? Animal A1 equals dog object. Dog is a lower type data type, animal is higher type. So this is widening, and Java does implicit typecasting, and hence this is allowed, no worries. How about this? This is essentially the same statement, except we created a new object right here, right in this line itself. Alright, how about this? Living being, and again dog object. Living being is a grandparent of dog class, and hence we allow this conversion to happen, and Java does implicit typecasting. How about this? What we're trying to do here is narrowing. We're trying to convert higher type data type to a lower type data type. So this is not possible. This is going to give us a compile time error, and we're expected to explicitly typecast this object to dog, to the destination type. In this case it's dog. Same is the case with this instruction. How about this? Cat and dog are two different data types, and Java does not support typecasting either implicitly or explicitly for objects of two distinct types. How about this? Again, it's two distinct types, cat and dog. Even if you do explicit typecasting, Java does not allow us to do so. It will throw a compile time error. This statement, it is possible, but trying to explicitly typecast animal object to dog. But do take a note that this is actual animal object to where this reference type is pointing to. And we're trying to convert this object to a more specific data type, dog. This looks as though it's not causing any problem, but when we run this program, it is going to cause a problem. Let's save the file and try to run the program and see the error. We got class cast exception. Ignore all these statements because this is from our previous programs. We're just calling the constructors. What we're interested in is this statement, class cast exception. Animal cannot be cast to dog. Makes sense. We'll talk about exceptions in our future videos for sure. Let's comment. Let's uncomment this line and this line. Now what's happening here? In this case, we are trying to achieve narrowing by trying to convert animal to dog, but take a note that this animal reference type is ultimately pointing to a dog object. So this is not going to yield any errors. Let's try to run the program, and there you go. No errors or whatsoever. Let's save the file. How about this and this? Object is a class that is parent of each and every class in your project. If you don't define an extends keyword to extend the behavior of your class, implicitly Java will extend this class object. So all these three instructions are perfectly valid. We're doing widening. Great. The real usage of typecasting will be explained when we talk about runtime polymorphism. See you in my next video. In this video, we're going to talk about final keyword for methods and classes. Take a look at this example. Let's say we have this method which will just print how many legs does a dog have. I have another class which is German Shepherd class, and it extends the dog class. What this class does is it has overridden the behavior of the dog class for the method number of legs, and it has its own instructions. In this case, it's printing a wrong message. German Shepherd have 2 legs. This could be accidental or intentional. This is certainly not right, because every dog will have 4 legs and it can never be changed. In case if I want somebody to use my class, I mean extend my class dog, but I don't want them to override this method. For that, I just have to use the keyword final. Now we get an error here saying remove final modifier of dog number of legs, but we don't want to. We just want to get rid of this method instead. Hope that makes sense. And if you don't want the class to be extended at all, then you would mark the class as final. Again, we get an error here because the type German Shepherd cannot subclass the final class dog. So we can't extend that class anymore. When you have a class as final, there's no point or there's no meaning in having final methods. That's because anyways we cannot extend this class, so there is no possibility of overriding anyways. So far throughout our course, we have used final class. Can you guess what class it is? It's a string class. That's because, as we know, string is immutable. It is immutable because the string class is final. Alright, this might sound confusing a little bit, but we'll understand it at a later point of time. But for now, If you have a class as final, then you can never extend it. And as a rule of thumb, whenever you write a class, keep inheritance in your mind. Design the class in such a way it will fit for inheritance. In case if you're not thinking about inheritance while writing a class, then just mark that class as final. I hope that makes sense. Now another thing which I want to talk about is static binding and dynamic binding. Binding refers to a bond between method call and the method definition. This is the method call and the method definition is this. During the compile time itself, the compiler knows which method to call. So this is called static binding. This is also called early binding. Coming to dynamic binding, the binding between the method call and the method definition does not happen during the compile time. That's called dynamic binding or late binding. And this is a perfect example for that. Hope that makes sense. If you're ever calling a method which is static or final or private, then there is no scope for dynamic binding. That's because a private method can only be called from within that class, and hence there is no overriding or polymorphism concept. Hence there is no dynamic binding or runtime polymorphism for that method. If you're talking about final method, then that means that method can never be overridden, and hence again there is no polymorphism here. So it has to be a static binding. And if the method is static, then it's not even associated with the object. The method is associated with the class, and the method gets executed when the class first loads. Again, even in this case, there is no dynamic binding. See you in my next video. In this video, I'm going to talk about abstract classes and abstract methods. A class is said to be abstract if it has at least one abstract method. But what is an abstract method? Take a look at this example. We have an animal class, and inside that we have this method shout. If you observe, there is no specific sound that every animal makes. Dog will shout like a dog, maybe bow bow, and cat will shout like a cat, maybe purr, something of that sort. So it's not really appropriate to have this method in the animal class. One solution for this is to override this method and give dog its own behavior. For example, I just copy this, paste it over here. With the override annotation, I'm going to say bow bow. Great, but this doesn't really solve the problem. The reason is, let's say we have another animal class, maybe say pig. It's going to shout differently. And let's say I forgot to override this method shout in the pig class. Now when I create an object of pig class and call this method shout, it's going to result in calling this method, and the behavior is inappropriate. Pig's supposed to shout like maybe oink, oink, but it's going to shout differently like an animal, which is completely inappropriate. So what is the solution for this? We use abstract methods. An abstract method does not have any implementation at all. That means we just simply get rid of this. There should be nothing inside this. And since there is nothing, there is no meaning of this curly braces. We delete that as well. But every statement ends with a semicolon, and we end with a semicolon. The reason why we have error here is we haven't yet marked this method as abstract. And when we have at least one method which is of abstract, we're going to have to take care of marking that class as abstract as well. When we have a class as abstract, there are two things that's going to happen. One is whichever class is extending an abstract class is forced to give implementation for all the abstract methods. So I'll have to copy this,
And actually we do already have that method implemented in here, and there is no purpose of override annotation here because we are now forced to give implementation. But in cat class we don't have the implementation for the abstract method shout, so that's what we're going to do. Copy this, and shout like a cat, whatever. We have another error here. Let's see what it is. Alright, we get rid of this word abstract. Well and good. Now the second thing that's going to happen when you mark the class as abstract is nobody can ever create an instance of this class. And that makes sense because there is no implementation for this method. For example, I create an object of this class animal and I call this method. Where are the statements? Where is the implementation? What would be the behavior? There's nothing. A class which is incomplete. So that's why we have errors in here. We can't have an object of that class. But what we can do is this. We can have an object of its child classes and have the reference type as animal. By doing so, you can always call the methods inside the animal class as well anyways. Hope that makes sense. Now just in case if you don't implement all the methods, for example I get rid of this in here, then you're going to have to mark this class as abstract too. By doing so, whichever class is extending the dog class will have to give the implementation for this abstract method. So inside our German Shepherd class, we're gonna have that implementation. But looks like we have an error here. Can you guess what this error is? Alright, the error is for this. We can't have a class which is both final and abstract. Now can you guess the reason? That's because when we make a class as final, then we cannot extend this class. And without extending, we cannot give implementation for abstract methods. So it has to be either one of these. I'll get rid of the final in here. And let's get rid of this object as well, because that's going to cause compile time errors. Now since dog is also an abstract class, we can't create an object. Let's get rid of that keyword. And let's put back that method. Alright. Now you would definitely have errors in here as well, since we've made the animal class as abstract. So let me just comment that out. And I guess you are capable enough to deal with these errors that are going to come inside this class. Alright. Earlier we had talked about access specifiers, but we haven't yet talked about the protected access specifier. This is the right time for that. When we have a member as protected, then that member is accessible in all the classes in that package as well as the subclasses in other packages. That's exactly what I'm demonstrating here. For this purpose, I have created a couple of packages. In one package we have the animal class, which is this. In this animal class we have a constructor which is of protected. We have a member variable which is protected, and we have a member function or member method which is protected as well. We can't have a class as protected. So all these members should be visible in all the classes in the same package. So this is a class in the same package called cow, and I'm able to create an object of animal class to access its member methods. And this is working. Let's run the program. There you go.
It called the constructor first and then the method. Now we have another class inside another package with the same name, cow. In this class we have the public static void main method. We have this method just to be able to call this method in here, some math, so that we can demonstrate what is happening. This cow class extended the animal class in here by importing it, and as expected, the cow class constructor can call the superclass constructor because it is protected and is visible. Similarly, we can call the method inside the animal class, and also we can access the variable. Let's run the program. There you have it. Let's say we want to get rid of this, then we get errors, obviously. Now you might wonder why this is not showing an error. By default, this has actually extended the object class. So this instruction would call object class constructor. Let's undo those changes. Now let's see if we can create an object of this class just as we did here. In the main method, we cannot because there is no visibility of this. Even the constructor is protected. We can't instantiate like this. Let's save the file, and that's it. See you in my next video. Garbage collection is a process that happens periodically on the heap memory. What this process does is it will scan the entire heap memory and it collects all the objects that does not have any references. Ultimately, all these collected objects would get destroyed out of the memory so that the memory will get freed for new objects to get created. So when do we say an object does not have its reference? There are primarily three cases where this can happen. Take a look at this program. In the first line we have the dog object. Now D1 is made to null. That means this reference type is not pointing to any object in the heap memory. Now this object does not have any references, so it qualifies for garbage collection. Similarly, here we have a couple of objects of class dog. D2 is now pointing to the D3 object, which is this. So this object in here will qualify for garbage collection. And in here it's pretty straightforward. We don't even have the reference type. So it's just plain object, virtually useless. So even this object will qualify for garbage collection. Another thing I want to talk about is the finalize method. Finalize method is method inside the class called object. And as I've mentioned, object class is the parent of any class in your project. Take a look at this class. The dog class is extending animal. Let's press Ctrl and then click this to open the file. Now animal is extending living being. Now living being is actually extending the object class implicitly. Even if you don't give the statement, it is doing the same. You give it or not give it, the result is same. So now going back, before the object gets garbage collected, the Java virtual machine will run the finalize method of that object. In this case it's dog. So why do we have the finalize method? Is to free up any open files or database connections associated with that object. We don't want to keep the connections open, etc. We're going to talk about streams, database connections, all such sort of things in future videos. But for now, just think of it this way, like we should not be keeping any open DB connection when we are destroying the associated object. That will be taken care by the JVM itself. But in case if you wanted to override that method, you can do that. For example, you can say, I don't want JVM to perform its own action. I want to do something with the finalize method when my object is getting destroyed. In that case, you can always override that method like so. So we have overridden the finalize method from the object class, and we're just printing the statement. Every time the object gets garbage collected, before that happens, JVM will call the finalize method automatically. Now I said garbage collection is a process that happens periodically. That also means that it is not guaranteed. So if I run this program, there is no guarantee that the garbage collection process kicks in. In order to kickstart the garbage collection process explicitly, you're going to use the method inside the system class, which is system.gc. GC stands for garbage collection. If we run this program, then every time an object is getting garbage collected, it's going to call that object's finalize method. In this case, we have overridden that method and printing the statement. So ideally, since we're losing references for 3 objects here, we should be seeing this message 3 times. Let's run the program. There you go.
Alright, in this video I'm going to go a little bit deeper and make you understand this statement, system.out.println. Especially we're going to give attention to one of the methods inside the object class, which is toString method. In here I have a couple of lines of code. In the first line I'm just creating an object of string class, and I'm passing that object as an argument to the println method. But there is a lot going on behind the scenes. To analyze what's going on in this method println, I recommend you to go to this website, grepcode.com. In here, search for the class that you're interested to look at. I type in system, and then under this section, open JDK, click this link. This website will allow us to analyze the source code of the class files that you find in the JDK. Inside the system class, we must be having a static member variable, which is with the name out, and that's how we're able to call that member using the class name. So this is what it is. We have a static variable out, which is actually an instance of the printstream class. Let's click that, and inside this printstream class we must be having the println method. As you can see, we have many println methods. So what we are trying to achieve here is overloading. We had already taken a look at the example of overloading in our previous examples. Now out of these methods, when we are passing string as an argument, where would the controller go? Can you make a guess? It's obviously this, because in here we're taking in string as an argument. Let's go inside it. Inside that method we're calling a couple of other methods. One is print, the other is the new line. We'll talk about the print method. The new line method in here will just have some instructions which will help in printing a new line on the console. Essentially this is as good as pressing a written or enter on your keyboard. But what we're interested more is this method, print. We're calling this print method and we're passing the exact same argument, which is string. Let's see what happens inside the print method. Inside the print method, we're just checking to see if the object is null. If not, then we're going to go ahead and call this method write. Write is the method which does all the magic. That's where we see the code that will ultimately print the string onto the console. As simple as that. Now let's go back to our code. But what if we send an object to this println method? Let's take an example of integer object. You can think of integer object as the object representation of primitive type int with some extra capabilities. We're going to go and understand these classes at a later point of time when we talk about the wrapper classes. But in here, if you run this program, it's just going to print the value 1000. Here it is. Now let's dig in and understand what's going on behind the scenes for this instruction. Again, we're in the print stream class. Inside this, can you make a guess on where the control would go if you're sending the integer object as an argument to the println method? It's going to be this. Let's dig in. Inside this method, we have the same exact methods what we had inside the println method when we pass string as an argument. But before we call these methods, we're trying to do something in here. We're trying to convert the integer type to a string type. How is this done? Let's go inside this method. We're going to call the value of method, which is inside the string class, and this value of method is going to take in this argument, the object, which in this case is integer type object. And this is possible because object class is ultimate parent of each and every class in Java, and integer class is no exception. Since integer is of subtype of object class, we can comfortably send that as an argument to this value of method. Now let's see what's happening inside this value of method. It's a pretty simple method. It just checks to see if the object is null. If it is null, we're just going to see this result null as a string in the output. For example, let's just go back to our code and let me just demonstrate the same. For example, if you make this null and save the file, and if I run it, it's going to show the null. Essentially what has just happened is, let's undo those changes. This method returned null. However, if the object is not null, it's going to call the toString method of that object. And currently this object is of type integer object. Now this gets a little tricky in here. We have overridden the method toString. The object class has the toString method, but the integer, which is subclass of the object class, has overridden the method toString. When we do object.toString, the control will go inside the toString method inside the integer class. Let's dig in. What we need to search for is integer. Again, we click this link. This integer class has the toString method. Here it is, which is overridden from the parent class object. And here we're just having one line of code in which we are calling the value of method inside the string class. But can you make a guess on what would be the value here? If you go back to our code, we have passed this value to the constructor of the integer class. And that constructor has initialized the value to whatever the value that you sent. In this case, it's 1000. Let's go back. So we're passing the primitive type int. By the way, this is the value is of type is primitive int, and we're passing that as an argument to the value of the string class. Inside this, we're again calling the integer class toString method with a couple of arguments. So this toString method is going to call the toString method with 2 arguments inside the integer class. This is where the magic happens. Basically, this is where the conversion of the int to string will take place. So we're returning the string object from this method, which then goes back to the calling method, the value of, and ultimately we're returning the string object. Only after which we're going to call these 2 methods. And we have already talked about these 2 methods. Hope that makes sense. So in short, this statement has converted the integer type object to a string object, and then we can comfortably pass that string as an argument to the print method, where the actual printing of the string on the console will happen. Let's go back. But what if we're sending a primitive type int? For example, int I equals 10, sys out, control space, and you print the value I. This println method is going to call this method, and it's pretty simple. It's going to call the print method, and again the write method inside this is going to take in only the string object as an argument. So before we pass the argument, we're going to convert this primitive type int to the string object. And how do we do that? Is we send the int primitive type as an argument to the value of method inside the string class. Again, we're calling the toString method inside the integer class with couple of arguments. And ultimately we're sending back the string object, which comes back here, and we send that as an argument to the write method. And obviously these are just set of instructions that will print the string onto the console. So there is a lot going on behind the scenes, and everything is abstracted for your convenience. Isn't that amazing? Now let's take a look at something really interesting. Let's say I have created an object of my own class, cat object, new sysout cat object. Can you make a guess on the result of this statement? Let's run this program. You would see some random text. So what has actually happened here? Let's take a look. When we send our own object, it's going to call this method println, which takes in the object. And obviously before it does this job of printing onto the console, we need to somehow convert that object to type string, which we then pass as an argument to the print method. So let's dig inside this value of method. And obviously we didn't send the null, so the control would get to this point, and this would call the toString method inside that object. Now if you take a look inside our cat class, we don't have the toString method. So this is going to result in calling the toString method inside the object class. Now what does the toString method inside the object class do? It's going to simply print the hash code of the object. Now what is a hash code? We're going to talk about it when we talk about collections. You can think of hash code as a unique identifier for an object, but it doesn't necessarily have to be unique. We'll talk about it at a later point of time. Let's go back to our program and run this program. So the way the hash code is represented is we have the name of the class, the @ symbol, and then the hexadecimal representation of the memory location of that object. In this case, it's a cat object, and that's what it is printing. Obviously, from the user perspective, this doesn't really help. So can you make a guess on how do we handle this situation? We will override that method toString. Let's make sure we are indeed overriding this method. We're good. Now if you run this program, due to the polymorphic behavior, it's going to call the toString method of the cat object. Now this makes sense. User can understand it is indeed a cat object. Pretty interesting, but it might take a while to digest. If you have any confusion, just go through this video a couple of more times. It's okay to go through the videos again and again until you are pretty comfortable with the concepts. See you in my next video. In this video, we're going to talk about enum type in Java. Let us assume that you have to write a navigation code for your robot. This is how the code would look like. You'll have a method that will take in a string as an argument, and we're going to pass that string to this switch statement, and based on the argument it's going to choose the direction. For example, if I pass in east, then these two lines will get executed. Essentially, we're going to let our robot turn towards east. Similarly, if we pass south, the robot is going to turn towards the south. If none of these cases are met, then we're going to just say the robot to don't turn at all. In here, I have the object of the same class, so that I could call this method turn and pass in some argument. I'm passing in east as an argument, and I would expect the controller to get inside this section of code, and I would like to see this message printed on the console. But let's see what is going to happen. Don't turn. It has entered inside the default block. The reason is the case. Here we have the lowercase e, and whereas we're passing in the uppercase e. This is clearly a problem. We have left some room for mistakes. Even though I'm intended to enter east, I ended up getting inside the default block, which is not my intention. So you have to take special care in giving the exact case name what you have in here. This is very difficult. Let's say you took a .class file from someone else and it has a similar method, then how would you guess which argument to pass? It's a nightmare. It's just, you have to go in trial and error approach until you get successful. This is definitely not feasible. We need to address this problem. We also have another problem in here. You could create, or somebody else can create, a case which is completely unrelated to navigation or direction, whatever. You can just have some random case in here. Obviously there is no such direction as SDF, 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 etc. So this is another issue we have. How do we address this problem? One of these problems can be partially addressed with the use of a class with some fixed constants. Like we have 4 variables in here: east, west, south, and north. And as you know, we follow a good naming convention for constants is to have all capital letters. It's just a good naming convention. We can make a variable constant when we have the static final keywords and fixed before that variable, and we have the associated values. Now instead of sending a string, I'm just going to send one of these variables inside the direction constant dot. Now we only have 4 options. We can only send one of these 4 variables. This is going to run smoothly, but still we didn't fix the problem entirely. Still there is a possibility to send some random text. How do we fix this problem? The answer is enum type in Java. Just as class, a user-defined data type, enum is also a user-defined data type, but the difference is enum is specially tuned for this purpose, to address these kind of problems. Let's see how we can create a enum type. Right click on your project, right click on your package, go to new, and then choose enum. Give it some name. I'd like to give the name as direction, and click finish. We have the direction enum in here, and we can just have some variables. We can have north, east, south, west. We end with a semicolon. Now how is this enum type solving our problems? Let's go back. In here, instead of sending string as an argument, I'm going to send the enum type. I'll do Control C and Control V. Now doing so, we are forced to fix those 2 problems. In here, I cannot have any case that is not part of this enum type. So there are only 4 possible values. Hence, there are only 4 possible cases I can have. So it has to be east. I cannot have any other name here, including the case. You can't have a small or lowercase t. It has to be capital, whatever you have it in here. Similarly, west, south, north. One of the problem we had is now addressed. The other problem is leaving the room for sending any random string. And in here we have no other option but to use one of the values defined inside the enum type, direction dot east. Now this has fixed both of our problems. Now let's understand a little bit about the enum type. In here we're able to access the variables inside the enum class just by using the class name. What this also tells us is that the east in here is a static variable, and that's exactly what it is. If you were to write the class representation of this enum, then it would look something like this. We're going to have public static final, and then north, similarly for rest of the variables, and we're going to have a static block that will do something. We'll get what these instructions are doing in here in a while. Let's go back. Now let me just talk about something really interesting. In here, let's just comment out this code. I'm just going to use a simple statement, sysout, and if I do direction constants, the class file that we have, .east, what is this going to print? Obviously this value east, right? But what if we use an enum constant? Can you guess the output? It's going to print exact same variable name. So what's happening behind the scenes? In here, when you access this variable, it's going to straight away give back a string. But whereas when it comes to enum, there's a lot going on behind the scenes. Let's dig in. When we have the statement direction.east, it's actually returning an object, and we are calling the toString method of that object. Let me explain you what I mean. If you take a look at the class representation of this enum, in here we obviously have a final static variable, and the value of that variable is not a string. It's just going to be the same object. We created a new object of the same class, and we're calling constructor with couple of parameters in here. What are those parameters? One is the exact same word what we have here, the variable name, and the other is ordinal. We'll talk about ordinal pretty soon. So this is going to result in calling this constructor with couple of arguments, and inside this constructor we use the word super to call the superclass constructor. Now what is the superclass of this enum type? By default, implicitly, any enum type is going to extend a class called enum, and inside this class, if you go inside the source code of it, let's go to its source code. Again, you can use the website grepcode.com to find the enum class, which is part of java.lang, and in here we must be having the constructor, which takes in a couple of parameters. Here we have it. This constructor is of protected, and this constructor is just setting the initial state for a couple of variables. One is the name and the ordinal. Now do take a note of this. We're going to see how we're going to make use of this name in a moment. Let's go back. Now we had talked about the toString method in our previous video. Same thing is going to happen here. We're going to pass this enum type as an argument to the println method. Ultimately, it's going to result in calling the toString method of the same object, which in this case would be the enum class. So in here we have the toString method, and it's just simply returning the name. Now we know what this name is, the exact same name as a variable, and that's why we're able to see this name in here instead of some kind of a value. Hope that is clear. Now besides just setting the name, we had also set something called ordinal. What is an ordinal? You can think of ordinal as the position of a particular variable starting with 0. The ordinal of north is 0. The ordinal of east is 1. South 2, west 3. And that's exactly what we are setting. 0, 1, 2, 3. In the same order we define inside the enum type. In order to get the ordinal value, we can call the method ordinal. I would expect the result to be 1. Let's run this. When are we going to use this ordinal is something we'll talk later when we talk about enum maps, etc. Alright, I guess that's enough for this video. We'll talk more on enum in our next video. Another method which I would like to talk about is the values method. Let's look at what it is. The values method is essentially going to return list of all the variables we have inside the enum. So that's going to let us loop through all these variables and do something with them. Let me just explain you what I just meant. We have we can use a for loop. Int I equals 0. I is less than direction dot. See, we have the values method dot length and then I plus plus sysout and direction dot values of I. We have all these. Of course we can get rid of this statement. So now we have all these list of variables in the same order how we defined inside the enum class. Now this is a very bad approach of looping through all these enum constants. There's a better way of doing that. We can use for each construct for this purpose, but we'll talk about it at a later point of time. For now, you can just simply follow the for loop. Sometimes you might want to set some variables associated with each of these constants. For example, when it comes to direction, we can associate it with the degree. For example, say for north, it's going to be 0 degrees. For east, it's going to be 90 degrees. And for south, it's 180. And for west, it is 270 degrees. The way we deal with this is we're going to have our own constructor defined to set a state. Let me just explain you what I meant. We can have, for example, 0 for north, 90 for east, 180 for south, 270 for west. Now obviously we have an error here. Essentially we're passing in an argument to the constructor of the direction object. If you go back and look at the source code, the class representation of this enum type, in here we're passing a couple of arguments by default. In addition to that, now we're having a third argument. So the constructor direction int is undefined. Now obviously we have an error here because what we're essentially doing in here is we're passing in an argument of type int to the constructor of the same enum type, but we don't have a constructor that takes in this argument, so we'll have to define one. We're going to have a variable int, let's call it degree, and we're also going to have a constructor which is private. We cannot have a public constructor inside the enum type. We'll talk about it pretty soon. Direction int d degree equals D, all well and good. The only thing that is left is to have a getter and setter for this variable. Source code, generate getters and setters, choose a variable and click OK. Now that's the beauty of IDE. It will provide a lot of convenience for the programmer. Let's make this private. Now these values are set. In order to access them, you can just now say dot get degree. Let's run the program. 0, 90, 180 and 270, and you can do something with this. So that's the beauty of the enum type in Java. Unlike enum type in other programming languages, Java enum will give you more flexibility. It will allow you to have methods, variables, constructors, etc. So that's a lot of flexibility provided apart from just set of fixed constants. Talking about methods inside the enum type, we can have methods. We can also have abstract methods, but I'll talk about it at a later point of time. For now, let's just quickly point out some of the important points to remember for enum. If you look at the class representation of enum, by default it is extending the class enum. What this also means is you cannot have another class extending, because in Java we don't support multiple inheritance. So if you say extends something, then it's going to throw us a compile time error, because we have already extended the enum class. Hope that makes sense. Also do take a note that all the enum types are implicitly final, which also means that we cannot extend the enum type. Now you may have a question: if we have abstract method inside the enum class, how are we going to override without ever having a child class of this enum type? We're going to preserve that topic for a later time. Another point to remember, as I've already mentioned before, we cannot have a constructor that is of public. If I try to define one, it's going to throw a compile time error. Illegal modifier for enum constructor, only private is permitted. And due to that reason, we cannot have an object created using the new operator. In our code, we can't use the new keyword for enum type. For example, I can't do this. Let's undo. In some cases, you might just want to use the enum constant in a particular class. You don't want it to be accessible across the project. In that case, you can always have the enum. You can just copy this code, Control C, and you can just have it on top of this class. That way this is accessible within this class alone, not the entire project. Let me change the name, something like that. It's going to, now you can just use this just as before. Hope that makes sense. Let's undo all those changes. Alright, that's it on the enum type for now. Okay, one more thing. We've talked about the values method, but do you know where is this coming from? You may guess that it might be coming from the enum class, which is inside the lang package, java.lang, but that's not true. This values method is not part of any class. The source code of this values method will be generated by the compiler, because the source code inside the values method is dependent on the values that you set in here. So it is dynamically generated by the compiler. This is an exception case. Normally compiler wouldn't take care of putting the source code, etc. It's just going to do a conversion from your source code to a language that the Java virtual machine can understand. Nothing more than that. But this is an exception case. I think it's worth noting that point. See you in my next video.
I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.